Section 1.3 deals with solving equations with a variable on both sides of the equation. We are also going to learn about some special solutions to linear equations. Now to solve 10 minus 4x equals negative 9x. Since on this equation we have an x on both sides of the equation, we have 4x here and the negative 9x here. We need to put those two sides of the equation together. So if we add 4x to both sides, that leaves us with 10 equals negative 5x. Divide by our negative 5, and negative 2 equals x. And we can do our check. So 10 minus 4 times negative 2 equals negative 9 times negative 2. 10 minus negative 8 equals 18. It checks. And the next example problem is, to solve this problem, we do have an x on both sides of the equation, but we do have some work to do before we can move the x to one side. So we have to use the distributive property on both sides. So the 3 times 3x, we have 9x minus 12 equals, and 32 divided by 4 would be 8x. Plus 56 divided by 4 would be 14. Now I can move my x's together, and we can subtract 8x from both sides. So that way we have 1x, or we can write just x in that case, minus 12 equals 14. Subtract or add 12 to both sides, and x will equal 26. Now to do our check, when you put 26 in for both of those x's, you should find the check works. Sometimes when we're trying to solve an equation with a variable on both sides, we run into a problem where, as we're solving the equation, the variable disappears. And here's some cases where that happens. For this problem, we have a variable on both sides of the equation, here and here, but we need to use the distributive property first. So we have 15x plus 6 equals 15x. Now, when I subtract the 15x to move it to the other side of the equation, we're left with 6 on the left side and 0 on the right side. Now, in this case, when our variables cancel out on us, so we cancel out the variable on this side, and we cancel the variable on this side, the equation that was left for us, 6 equals 0, that is a false equation. That means there is no solution for this problem. There's not a real number for x that will solve this equation. So this one has no solution. And now we'll see what happens when we try to solve this equation for y. When we solve this problem, we get negative 8y minus 2 equals negative 8y minus 2. We add 8y to both sides, and we're left with negative 2 equals negative 2. Now, in this case, this equation that we're left with, after our variable cancels out, we're left with this negative 2 equals negative 2. In this case, negative 2 does equal negative 2. So this equation actually has infinite solutions. Okay, so now if I take any number I would like and plug it into this equation, we'll get a true statement. So let's say I choose to plug in 1. And we're left with negative 8 minus 2 equals negative 8 minus 2. True. If I plug in 3, so we're left with negative 2 times 13 equals, on this side we get negative 24 minus 2. We get negative 26 equals negative 26. So any number, real number that we plug in for y will give us a solution. So as a reminder, if the variable cancels out while we're solving the equation, if the leftover equation is true, there's infinite solutions. If the leftover equation is false, there is no solution. So once again, in this case, when we subtract 3y from both sides, the equation that we're left with, negative 4 equals 8, is false. So in this case, we have no solution. Now on this equation over here, when we add 7x to both sides, we're left with 5 equals 5. Now in this case, that equation is true. 5 does equal 5. So our solution in this case is infinite solutions. I hope you enjoyed your lesson with solving equations with a variable on both sides.